All right, greetings YouTube, beautiful mind here, aka Professor C. Let's see, let me see if I can think of any announcements. Let me make sure you guys can hear me. Yeah, it looks good. Okay. So, I take attendance as I let students in. So once you get into my Zoom, you have your attendance credit. I'll let you kind of decide what you do from there. Let me see. So I loaded a couple of more assignments today for week 3. We're at the second half of week 3. I think we finished out the homework that was already assigned. So I went on and gave us some more practice on factoring because I know that college algebra students typically, even though you're expected to already know factoring, I went on and added a couple of assignments to get some practice on factoring. So I just made those like maybe 10 minutes ago. So those are available. So today we'll take some time to go through the first of the 2 assignments, and we'll take time tomorrow to go through. Feel free to type in the chat or unmute yourself if you have questions or inquiries. Otherwise, let me see if there's anything else. Also next week, wherever you are in the country, hopefully you're someplace warm and safe and you're able to do what you need to do. I know that a lot of people are experiencing bizarre weather. The weather here in Atlanta was beautiful today. It was a little overcast and rainy, but it's not like what everybody else is experiencing. On top of that, apparently, I guess it snowed in like Saudi Arabia. So, hopefully you got your stuff in order. If that's not a sign of the times, I don't know what is. You know what I mean? So, just do what you got to do. Keep your head on straight. Keep your head high. And just kind of keep moving. Keep taking steps. Keep stepping forward. All right. So we're going to do that. So with that being said, we're going to just kind of hop into the material for today. Okay. So this is a supplemental material. It's just practice on factoring. It is part of our grade. Basically what we need to be doing, any assignments that we see on Pearson, we access it through Blackboard. It's going to be incorporated into our grade. Our grade is going to basically come from the assignments on Pearson. Attendance, I take attendance, but I really only use that for record keeping, right? I just use that for records. I don't factor that into the grade. It only becomes an issue if we rack up 4 or more unexcused absences, then you can potentially be automatically booted from the course. But yeah, okay. So we're just gonna be practicing factoring today and tomorrow, okay? Special factoring, okay. So this comes from an alternate text. Let's see, let me start my notes. So this is week 3. This is going to be special factoring. I think also exam 1, and we can anticipate exam 1 to become available starting next Wednesday, from next Wednesday until Sunday at midnight, going into Monday. It's due that Sunday night going into Monday. We can anticipate 1 exam every month, right? Pretty much towards the end of the month. Unlimited attempts at all assignments. On all of our assignments are due on a weekly basis, Sunday night at midnight. The exam is going to cover basically sections 1.1, 1.2, 1.1 through 1.4. The factoring is just supplemental material. It's not going to be directly incorporated into the exam, but you can't really do this stuff without knowing factoring. We're supposed to already have mastered factoring by this point, but I know a lot of students haven't. So that's why I've incorporated supplemental material. Okay. I think the chat looks good, so I'm going to kind of let that be. And I'm just taking some notes on this first question. So this is question number 2 from this assignment. It comes from an alternate text, alternate book. Okay. Let's see, determine whether the expression is difference of squares. There's no notes that need to be written, right? So it's just asking us a basic question. Do we have something squared minus something squared? Difference of squares is where we have something squared minus something squared. The first thing is being squared, but the second one is not a perfect square. So is this expression a difference of squares? No, that's it. All right, because we don't have something squared minus something squared. Okay, we're asked to factor. Notice here we do have something squared minus something squared. So difference of squares is one of the special factorings. is basically when you have a squared minus b squared, it factors into a minus b times a plus b. So in this case, it's going to be c minus 3 times c plus 3. Right? And you know it's correct because you would check this by foiling, right? If we foil, if we were to foil this out, first, outer, inner, last, right? Then we should finish with this result. Let me, before I submit that answer, I kind of want to see what does the book say about this. To factor any expression, first check for a factor other than 1 or negative 1. So basically they're saying factor out any greatest common factors or GCFs. There is no factor other than 1 or negative 1 in this expression, okay? So this is two terms, both squared in a special form. This is going to be difference of squares, right? Something squared minus something squared. Write the square root of the terms, okay? So we have m and 9 in this example. Now place those roots in the binomial factors. Okay, I was just kind of saying how did they explain it. Okay, yeah. So something squared minus something squared, a plus b times a minus b. Okay. So I'm just gonna go ahead with what we have and move forward. I was just curious if they explained it a little bit differently. All right. Do we have something squared minus something squared? Yeah. This is 7v squared minus 10 squared. So then this is just one of several. So we have 7v minus 10, and then we repeat that. Can I just copy and paste? Copy, paste, and then it should be a plus. All right. And then also we could check this by foiling. First, outer, inner, last. If we foil it out, the two middle terms should cancel, and we should finish with this. I'm just gonna kind of click it for now. Do we have something squared minus something squared? Yeah. Okay. So let's apply the same concept. The first thing, so r plus q minus 5 times r plus q plus 5, right? There are no like terms. If we were to expand this, I would treat r plus q just like one thing, but if you would expand it out, you can get back to where we started. Okay. I think the chat is okay, so I'm going to kind of let that be and kind of keep moving forward. Let me see. Okay? Let me write this one out because this one looks like we have to do it twice. So this is question number 6 from this assignment. It comes from an alternate book. We're asked to factor, and we have this a to the power of 4 minus 256. Okay. So let's hop over to the tablet. Let's see. Maybe it's showing properly. It looks like it is. Okay. So do we have something squared minus something squared? 256. 5 times 5. It's not 5. What's 4 to the power of 4? 4 times 4 is 16. What's 16 times 16? Hey Siri, what's 16 times 16?
16 times 16 is 256.
So this is the same as a to the power of 4 minus 4 to the power of 4, right? So notice we have something squared minus something squared. So then let me show it this way. We have a squared squared, and let's do this. So maybe this will help it to pop some. So we have something squared squared minus something else squared, right? So we have the blue thing squared minus the orange thing squared, right? We got something squared minus something squared. So then when we finish, it's going to be blue minus orange times blue plus orange, right? So hopefully that helps it to kind of come to life a little bit better, right? So we're going to have our a squared here, another a squared here. We're going to have our 4 squared here, and 4 squared here, and then one needs to be plus and one needs to be minus, right? Now, we don't have a rule for sum of squares, so this expression cannot be factored further. But we have another difference of squares over here that can be factored further. All right, so let's factor that one. So this guy just comes down. Let's copy and paste. And then something squared minus something squared. So then that can factor further into the following. We're going to have A, and then 4 and 4. Okay, and then plus and minus, right? So this should be the fully factored form of the original. We know we are in fully factored form because there are no greatest common factors amongst the terms, and we're finished. Everything is finished with multiplication or division. Right? So that's one indicator that we factored it properly. Okay, let's try this and let's hop back over to Pearson. Wait and see if this works. Okay. I'm gonna have to come looking for some of your brothers, because the agreement is you guys are supposed to be here at least to just check in. Even if you don't stay, I don't mind if you pop in and out, but I need you to check in. But I'm not speaking to the students that are here right now. But it's okay. I'll find them and we're gonna get to the bottom of this stuff. Okay, I'm gonna go with this. Looks good. Okay, let's keep it moving. All right, so this is factoring a trinomial, right? So we're looking for two numbers that multiply to give us 49 and add to give us negative 14. I think it's negative 7 and negative 7. So this one is just going to be v minus 7 squared. That's going to be v minus 7 times b minus 7. Try another one. Okay, so whenever we have 4 or more terms, we try factor by grouping. So I'm going to write this one out. So whenever we have 4 or more terms, we attempt factor by grouping. Okay, and then we try different groupings. Let's see. So this is question number 8. I'm going to say it comes from an alternate text. Okay. We're asked to factor. And we have b squared minus 2b plus 1 minus 49g squared. Okay, let's hop back over to the tablet for everybody. That should be showing. Okay, so again, whenever we have 4 or more terms, we try factor by grouping, right? Initially, I was about to factor it, group it like this. Like, let's look at the first two and the second two. But I think instead of grouping it that way, I'm gonna move this grouping and I want to look at the first 3 together first. Like if I consider the first 3, can we factor those by themselves, right? So we're looking for two numbers that multiply to give us 1 and add to give us negative 2. I think it's negative 1 and negative 1, right? So it looks like those 3 can factor into b minus 1 squared. Right, because it's going to be b minus 1 times b minus 1, right? And then the negative 49, that's not a 4. Given a banana attached to it? A daily dose of internet? Whatever. 49g squared, right? So now we have something squared minus something squared. So let's apply the same technique we were doing before. B minus 1 minus 7g. And then basically the same thing, b minus 1, instead of minus, it's going to be plus 7g. And I think that's it. Paste. Come on. This is kind of a tangent copy. While I kind of type, let's hop over to Pearson. I'm going to kind of just chat while I type this in. This is random, but I think they're about to release Matrix 4. And so I don't know how I feel about it. B minus 1 minus 7G, because the first Matrix is so spiritual, so philosophical. I was like, yes, they got it right? Even though it was stolen, apparently. Like, they stole that from this woman. I can't think of her name, but. And then the second two to me were just like action movies, so they didn't have like any depth to them. So I was like, I'm keeping my expectations low. I'm still excited, and I'm gonna watch the movie Matrix 4, but I don't know. Like, if they somehow bring back the spirituality, I will be like yes, you know, because that's what I long for. That's what I crave, all this spiritual depth or whatever, and like knowledge and know-how. But if it's just an action movie, I'm like, yeah, I wouldn't be surprised if it was just an action movie. So I don't know. We're gonna see what they were able to do. Okay, so with this next one, we're asked to factor completely. I'm definitely gonna write this down. There's way too much going on there for me, like just to glance at. So this is question number 9. I'm gonna say alternate book. Okay. It asks us to factor. Okay. All right. So we're gonna go 12c squared 36cg plus 27g squared. Okay. Also, some other announcements. I'd rather just do it instead of say it, but I've done it for one of my classes. I just got to take some time to do it for you all. But I still intend to update Blackboard with like an updated syllabus. Like in all these notes that you see me writing, like I guess we can hop to the tablet. All these notes that you see me writing here, I intend to make all these available. I just haven't finished setting everything up yet. So I did it for my other class. It took a good amount of time, but I did it. And so I want to do the same thing for you all. So just kind of be on the lookout for that. Okay, so first question we ask ourselves, is there a greatest common factor, right? So I'm thinking like 3 can come out of there. Well, actually 12 can come out of both of these. No, 3, right? Because this is divisible by 3. This is divisible by 3. This is divisible by 3, right? So there is a divisibility test for 3. How do we know if a number is divisible by 3, right? If the digits add up to a multiple of 3, then it's divisible by 3, right? So 1 plus 2 is 3. So this number is divisible by 3. You can test it. That's called the divisibility test. Just like if you wanted to know if a number was divisible by 2, then you ask yourself, oh, does it end in an even number or 0, right? If you want to know if a number is divisible by 5, does it end in 0 or 5? I know there's a divisibility test for 7. I think there are other ones. I'm not aware of them. I don't know how to use them off the top of my head. But for 3, you know, if the digits add up to a multiple of 3, then the number is divisible by 3. Notice 3 plus 6 is 9. This number is divisible by 3. This is 9. This is divisible by 3. Right? So we can at least factor out of 3. I don't think everything has a G. So I think the greatest common factor looks like it's just 3. Right? So we can factor out 3. We're going to be left with 4c squared plus 12cg plus, what is that, 9g squared, right? At this point, it actually looks like a perfect square trinomial. We have something squared, like perfect square trinomial takes on the form, this is a perfect square, this is a perfect square, and then this middle term is 2 times the first times the second, right? So if it's 2 times 2c times 3g, 4 times 3 is 12, cg, yeah. At this stage, it's a perfect square trinomial, so then we can do the following. It's going to be basically something square. It's going to be 2c plus 3g, right? And just do a quick check, like expand it back out or FOIL it out just to make sure that it works, right? If we were to FOIL this, first times first would be 4c squared. Outer times, here, let me write it like this. I'm going to off to the side here. This is my result. All right, I'm going to put this in a box because this is my final answer. And then I just want to do a quick check before I submit it. All right. So if we expand, we got this 2c plus 3g times 2c plus 3g. All right. If we FOIL, 2c times 2c is 4c squared. You can see it here. All right. First outer. So then 6cg plus 6cg is going to be 12. CG, okay, so that's outer and inner, and then last times last, 3g times 3g is 9g squared, okay, and then, you know, we can get all the way back to the original. Okay, all right, so, and that's not obvious, like even with like having to take it in a previous course, I don't think that's obvious. And so, and it usually trips students up, but you're expected to already know this. So that's why we have this lab with all this extra time, so that we can kind of like get some practice with these notions and provide an opportunity for you all to kind of strengthen these areas where we might be weak in. Okay. Let me see. Let's hop over to Pearson and see how do we do. All right, what's the time? I'm gonna have to mark. Let me see. It's been 15 minutes. Okay, let's submit this. So we got 3 parentheses. This thing is gonna be squared. We got 2c plus 3g. Boom. Okay. All right. All right. Okay, let me write this one out because this one, I feel like if you see it, it's a little bit easier to see than to explain. So this is question number 10. Question number 10. I'm going to say it comes from an alternate book. We're asked to factor. Okay. We got p plus q, quantity squared, plus 6 times p plus q, plus 9. Okay, let's hop over to the tablet and let me share my plan of approach. Okay. So here I'm gonna use a technique called U-Substitution. I'm gonna like put it into a form that looks more familiar. So I'm gonna say let u equal p plus q, right? So if we do this substitution, we get the following. We get a u here, a u here. It's going to be u squared plus 6u plus 9, right? So now this looks familiar. This looks like something that we're able to factor, right? Can we factor this into something of this form, right? Where we're going to have our u and u, 2 numbers that multiply to give us 9 and add to give us 6. 3 times 3, right? 3 times 3 is 9, 3 plus 3 is 6. So we're going to say plus 3 and plus 3. Okay. So then now we're going to substitute back. So put u back. So we got our plus 3 here. I guess it's just going to be squared. And u is p plus q. And that's it there. Okay. All right, let's see. Okay, let's hop over to Pearson and see how and check this. So we got p plus q plus 3 quantity squared. That's not a p. P plus q plus 3. Okay. Okay, let's go on to the next one. So this is another. These are all special factoring scenarios. So this one, ooh. That was a good stretch. It's kind of interesting because I'm actually about to go do yoga right after this. We're gonna get out of here and I'm gonna try to hightail it to a place where I can get some free yoga. Anyway, to factor here, so this is called different. So earlier I know we did a few examples where we had difference of squares. So this is called difference of cubes. Something cubed minus something cubed. Okay. So let me take some notes and we'll talk about it. Now I have a technique. I think I got this technique from YouTube that I'm about to share. And it's been working for me, so that's why I use it. This is question number 11. This comes from an alternate book. We're asked to factor. Okay. We have c cubed minus 64. Let's hop over to the tablet. Okay. Let me see. 4 times 4 is 16. Yeah. Okay. So we have c cubed, so that's going to be c times c times c. 64 is 4 times 4 times 4, right? So I'm going to use a technique called the chair method, right? So for the chair method, first thing, if we're going to factor this difference of squares, we got something difference of cubes, something cubed minus something cubed. First we're going to do two sets of blank parentheses. I like to call them biggie smalls, right? First we do a small set of blank parentheses and then a large set of blank parentheses. Okay. Because this is minus, we're going to use what I like to call, you know, the programming language C++. Well, instead of a C++, because this is minus, we're going to use minus plus plus, right? Minus plus plus, right? Another way you can look at this, because this is negative, the first one is the same, the second one is the opposite, and this last one is always plus, right? Let's look at it again. Because this is minus, the first one is the same, the next one is always the opposite, the last one is always plus, okay? Let me just move this over a little bit, okay? Actually, I think I'm gonna give myself a little bit more space. I wanna move all of this like this way. We can move you like this way, move you. I'm just making some more space, because I can. And let's move you like here. I think these are good. Okay, so I'm just trying to space it out. I could space it out more, but this looks good. Okay, so then the chair method, I guess we can do this. So first I'm going to circle these two on top. This is the first step, right? So that means my C and my 4 goes here. Next, I'm going to circle the 2 on the left. So this is my second step. C times C is C squared, right? Next, I'm going to circle the 2 in the middle. That's my third step. C times 4 is 4C. And last, I'm going to circle the 2 on the right here. That's my fourth step. 4 times 4 is 16, okay? Notice how the rainbow colors kind of make a chair. That's why I call it the chair method, right? So there was a progression there. First, we did a double set of blank parentheses, and I call it biggie smalls. So one set of small blank parentheses, and then a set of large blank parentheses. Because the given sign was minus, that means the first sign is the same, the second one is the opposite, the final one is always plus, right? Then, you know, we had C cubed, so that's why we said C times C times C. 64 was 4 times 4 times 4. Then we proceed to make the chair and fill it in with the corresponding colors, okay? So let's hop over to Pearson and see how do we do. Okay, the way I do that one is a technique called the chair method. Okay, so this is C minus 4 times, we got C squared plus 4C plus 16. Cross our fingers. That's good. Okay, again, this stuff is not obvious. All right. So I'm going to step up on the soapbox just a little bit. I'm going to try to be as concise as possible. Sociology majors. So one of the biggest challenges of being a college algebra student, most college algebra students are like freshmen, right? So, you know, this is different for everybody, you know, where you're forcing everyone to be remote and learn online. And so like if you don't have your mind prepared to be online, it's very easy to get left by the wayside because it takes a lot of responsibility. And so like if you're a freshman, it's very easy to like just be like, oh, I'm gonna just finesse or, you know, just pass the buck or like not do this or not do that and try to do it all, whatever. That's a dangerous recipe. I mean, you know, these things do have to be updated for the times, but it doesn't serve you to kind of finesse. I mean, maybe it does. Maybe you can become the ultimate finesse and become president like your former President Trump, right? If you want to be like Trump, be my guest, you know. But just be careful about trying to finesse everything. I mean, we're aware of it. It's like, but you know, everybody's doing the best that they can, and it's like, if that's what you're here to do, then you know, okay. But I don't know that that's not gonna serve you. It's gonna catch up to you. Like that stuff catches up. Eventually, you know, you're going to be tested, like, and you're going to have to show what you have and haven't learned, right? So, you know, just a word to the wise or a word of caution. You know, just try to have some integrity. But it's okay. You know, I don't know what I would do if I was in the same boat. This comes from an alternate text. Let me see this. This is another one, right? Alternate book. But again, this is like, and it's funny, I'm talking about having integrity as I'm doing like nefarious things in the background here. Okay. So this comes from an alternate book. We're asked to factor. Thank you. Hello, phone. We're asked to factor, and this one we have 125 plus v cubed. Again, all these items that you see me writing, I'm going to make this available. And then usually once I have everything set up, I push these notes and make it available for you right as I wrap up the class. Like as soon as we wrap up the class, it's usually available. I just have to finish setting it up. Okay, so again, this is sum of cubes. So the previous one was difference of cubes, right? Sum of cubes is essentially the same thing, and we just have to catch the changes, right? But there's a sum of cubes and there's difference of cubes. This one is sum of cubes, right? So what's being cubed? So first let's do our double blank parentheses, big E smalls. So we do a small set of blank parentheses and then a large set of blank parentheses, right? So instead of minus plus plus from difference of cubes, now this one, again, because the given sign is plus, that means the first sign is also plus. The first sign is the same thing. The second one is always the opposite of the first one. The last one is always plus. So whenever we're doing sum of cubes or difference of cubes, that's the setup. So I call this the plus sandwich. The previous was I call that like minus plus plus, kind of like C++. That was minus plus plus. This one I call the plus sandwich because, you know, your bread are the plus signs and you got the minus sign sandwiched in between. Okay, so then if we look at 125, what times itself 3 times gives us 125? 125 is 5 times 5 times 5. V cubed is V times V times V, right? Okay, let's do the same progression. So if we start with the back of the chair, this is our first set. The 5 and the V goes here. Next, if we over here on the left, that's the second step. 5 times 5 is 25. Then the seat of the chair, that's our third step. 5 times V is 5V. And then for the far right, that's the fourth step. V times V is V squared. Okay? So then that's the final result. So I can like still hear the music in my ear, gentle, soft. It's really nice. Like I'm just like vibing. I'm just vibing over here. Okay, so we saw sum and difference of cubes. Okay, we got to see the chair technique for both of those. Let's hop over to Pearson and see how do we do. Okay. We got 5 plus V, parentheses, 25 minus 5V plus V squared. Okay. Boom. That's good. Okay, we're going to go on to the next question. Yep, difference of cubes, let's do it. I don't think you can ever get too much. You can never get enough practice with difference of cubes, right? So this one, I'm going to kind of go a little bit faster though. This is 13. I'm going to say it comes from an alternate book. Rags to factor. We have 8x cubed minus 125, right? So let's hop over here like this. Okay, I'm going to hit it one more time. So this is difference of cubes, something cubed minus something cubed. What's being cubed in the first one is what? 2x, 2x, 2x. And then 5, 5, and 5, right? Let me give myself a little bit of space, kind of like this. And actually, let me move this a little bit closer and this one. All right, just kind of maximize my space. Let me do like this. This is as far as I can take that. I want this about that big, like that, right? Okay. So first question is, after we did our biggie smalls, small and large, right? If this is a minus, is this an example of the plus sandwich or the minus plus plus? This is an example of the minus plus plus. Minus plus plus, okay? So then if we do the chair, this is the first part, all right? So we have 2x minus 5. This is the second part. This is number 2. Number 2, 4x squared. This is number 3. Okay, 10x. And this is number 4. 25. Okay. And that's about the best we can do. Let me paste and do like this. Okay, that's fine. Okay, let's hop over to Pearson, like that. Let's see. So first we got 2x minus 5. Okay, and then we have 4x squared plus 10x plus 25. Okay. Boom. All right. It's kind of quiet, but that's okay. That totally takes getting used to, like not having an actual like live audience, so you have to like sustain it yourself. Fact of the polynomial, difference of cubes again. Let's knock it out. Let's do the thing. Do the thing, Julie. I wonder, do you get that reference? Do the thing, Julie. This is question number 14. I told it was just gonna say 4, and we're actually almost done with this. It moved a lot faster. I had to watch that later. Okay, 14 comes from an alternate text or alternate book. We're asked to factor. She kicked you out. What you in there doing? All right, we're asked to factor. We got this x cubed minus 8r cubed, right? Okay, let's hop over here so everybody can see. So this is difference of cubes again, something cubed minus something cubed. So first we're gonna do our biggie smalls, like this, small set and a large set. Then we ask ourselves, is this the plus sandwich or the minus plus plus? This is the minus plus plus. Okay. What's being cubed in the first term? X times x times x. What's being cubed in the second one? 2r times 2r times 2r. This is the first set, so we have x and 2r. Over here is the second set, we have x squared. The seat is the third set. We have 2xr. And the right side of the chair is our fourth set, so 4r squared. Okay, paste. It's the same thing, like once you get it, it's kind of like the same thing over and over, just with minor adjustments. Okay, let's check. Let's see. X minus 2r times x squared plus 2xr plus 4r squared. Okay. Cool beans. This still looks like a difference of cubes, so we're gonna keep going. All right. And the thing with these is like the first time you see it, it does kind of take a little while to like figure it out. And then the goal is like seeing the same thing over and over. That's how you increase your speed. You can't do something once and go like, oh, I mastered it. No, like you do it. If you really want to be good at something, you gotta do it over and over. You can't do something once and think you mastered it. You gotta do it, get as many reps in as you can. Anyway, let's see. so this is question number 15. Alternate text or alternate book. We're asked to factor. Okay, we got this 64x cubed minus 125s cubed. Okay, let's hop over here. Everybody should be able to see. We do have something cubed minus something cubed. Okay, so we're going to do our biggie smalls. Let me see, small set of blank parentheses and a large set of blank parentheses. Is this the C++? I mean, is this the minus plus plus, or is this the plus sandwich, right? This is the minus plus plus. Minus plus plus. Okay. What's being cubed in the first term is going to be 4x, 4x, 4x. What's being cubed in the second term? 5s, 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 right? That's not an s. Okay. Here, it's number 1. So that's going to be 4x minus 5s. Over here is the second one. 16x squared. The seat is in the third one. Third set. 20xs. And then the right. 25s squared. Okay, hopefully the colors are helping to bring that home. Okay. Okay. Let's hop over to Pearson. Right here. 4x minus 5s. 4x minus 5s. Then we have 16x squared, x squared, plus 20xs, plus 25s squared. Okay. All right. All right, I'm going to go on to the next one. Oh my goodness. 432 and 686. 7, 63, 8, 32. Okay, that's probably 8 over there. Let me see. 9, 10, 11, 12. 2 is 8, 13. 9 and 3 is. Okay, I'm trying to figure out what are those numbers being cubed. Well, there is a perfect square. Let me see, 432. Okay, I'm going to kind of play with the numbers a little bit. 432. Let me see. Hey Siri, what's 8 to the power of 3?
8 raised to the third power is 512.
All right, let's try 6. Hey Siri, what's 6 to the power of 3?
6 raised to the third power is 216.
7? Okay, I'm gonna try 7 one more. Hey Siri, what's 7 to the power of 3? Hey Siri, what's 7 to the power of 3?
7 raised to the third power is
Okay.
343.
So first I'm going to take out my greatest common factor, right? They're both divisible by at least 2. Let me write this down, and we're gonna have to play with this one a little bit. Okay. Because it's not, I wasn't sure if those are perfect squares or not. Okay. So this is question number 16 from this assignment. I'm going to say it comes from an alternate book. We're asked to factor. We have 432 c cubed plus 686 y cubed. Okay. Let's hop over to the tablet. All right, so I know we can factor out at least 2. If we factor out a 2 from everything, that's going to be, let me see. There's a 2, 1, 6. C cubed plus 343. I think we just got both of those numbers. I think 216 was the 4. Hey Siri, what's 4 cubed?
4 raised to the third power is 64.
maybe let's try 6. Hey Siri, what's 6 cubed?
6 raised to the third power is 216.
Okay. Hey Siri, what's 7 cubed?
7 raised to the third
Okay.
power is 343.
So now, when we go to factor this, well, first we know we got sum of cubes in this case, okay? I think that's 6c, 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 and 6c, and then 7y, 7y, and 7y, right? We had to just I just kind of went back and forth. All right, so I'll keep it for somewhere between 15 to 20 minutes more. I don't want to keep it for more than 20 minutes, okay? Okay. Okay, so next we ask ourselves, is this the minus plus plus, or is this going to be the plus sandwich? So this is actually, oh, and just for this to be proper, let me, this 2 needs to be here, right? So this is going to be the plus sandwich, right? Plus, minus, plus, okay? So if we do our chair, these are the first 2. So there's going to be 6c and 7y. We have the 2 on this side. 36c squared, 36c squared. 3, 36, 42cy, 42cy, and these guys over here. It's the 4th one. 49y squared. Okay. So hopefully those colors help it to kind of to see it better. But we're kind of doing the same thing with these sum of cubes and difference of cubes. Okay. All right, moment of truth. It's here. 2 parentheses 6c plus 7y parentheses 36c squared minus 42cy plus 49y squared. Okay. Let's see the time. We're almost done. If we make it to the end of this segment, then I'll let you go. Like if we make it before time, then we can stop. We got about 4 more questions we need to do. Is this 2 to the power of 5 is 32, 64? Okay. Okay, let's write this one out. All right, because there's a couple of things going on here. This is question number 17. Alternate book. I don't know why I keep writing like that. Alternate book. For Ask the Factor. Okay. And we have this a to the power 6 minus 64. Okay. Show it here. Okay. Let's see. Well, we don't. Okay. Man, that's a bit of a pain. Yeah, this one looks, I'm trying to think of the simplest way. So, because if we do cubed, all right, so this is what I'm seeing. All right, a to the 6, we can rewrite that as a to the 6, we can rewrite it as a cubed squared, right? Because if you say a power to another power, we multiply. So 3 times 2 is 6, right? 64 is 2 to the power of 6, so we're going to say minus 2 cubed squared, right? Okay. So in this form, the way we have it written, we have something squared minus something squared, so we can use difference of squares. So then this is going to be a cubed minus 2 cubed times a cubed plus 2 cubed, right? So then from here, we have to use the sum and difference of cubes, right? I think I'm just gonna write the answers. Okay, so if we focus on that first one by itself, it's gonna become a minus 2 times, is gonna be a squared plus 2a plus 4, right? That's the difference of cubes of the first binomial factor. We can also do sum of cubes, right? So for the second set, that's going to be a plus 2. Then it's going to be left with a squared minus 2a plus 4, right? That's the completely factored form of the original. That's why I was like hesitating for a moment. I was like, wait, let me think what I'm going to do here. Because it was clear that it was like multiple things in one go. Let me do like that. Let me do like this. I'm also going to shrink this down. Just trying to get it on the same page. Also want to expand this out a little bit. Then I'm going to put it back. All right, like this. All right, looks good. Okay. All right, let's hop over to Pearson. Let me see the time. Hop over to Pearson and let's check this. That's okay. Okay, so we have this a minus 2 times, we got a squared plus 2a plus 4 times a plus 2 times a squared minus 2a plus 4. Okay. Okay. So that one was fun. On to the next one. And like another thing, I was kind of hesitating initially. I was like, well, should we do a squared cubed or should we do a cubed squared, right? We could have did a cubed squared. Oh, that's what we did. We could have did a squared cubed. I felt like a squared cubed was going to be harder. That's why I was like, well, let's just try this and see what happens. Okay, looks like we need to do it again. This was a little bit different, but let's take a look at it. We're gonna write this down. I don't know, we might not get out of here early because these are taking a little bit. These last couple of ones are taking a little bit longer than I anticipated. Actually, let me do one other thing. I'm gonna just put this with that. Shrink this down. I don't want it like right here. That's about as big as I can make it. Okay. You can move it sideways. Anyway, that's about it. Okay. So this is question number 18. What's the time? Okay, it comes from an alternate book for X to factor. Now we got this 64r to the power of 6 plus 125g to the power of 3. Okay, let's hop over here. Okay. So can we get this to, do we have any, let me see, something cubed, right? Because we got a perfect cube on the right. Can we get a perfect cube on the left? Can we say something to the power of 3? 64, 8 times 8. So 2 squared to the power of 3. Okay. It looks like we can do 2r squared and then all of that to the power of 3, right? 2 to the power of 6 is 64, r to the power of 6, okay? 125g cubed. I'm gonna say equals. Now we have something cubed. Now we can do sum of cubes. I'm just gonna write the result here. So we're gonna have 2r quantity squared plus 5g, right? Let's see. So that squared is going to be 2r to the 4 plus minus that times that, right? I'm just gonna write the expanded number. 4 times 5 is 20 RG. 20 RG. And then the last one is 25G squared. Okay, well, let's do one more step. Let's expand our numbers. Can that be factored? 4 times 4 is 16 R to the 4. We need to make sure that can't be factored. That might be able to be factored. That final trinomial. All right, let me take some time here. Let me expand these numbers. Let me see, is that going to help us? Okay, so this first one becomes 4R squared plus 5G. So that, I think that one is done. Over here, 4 times 4 is 16. 16 R to the 4 minus 20 RG plus 25G squared. Can we find, before I submit this, can we find two numbers? What's 16 times 25? If you have 16 quarters, right? 4 quarters is $1, so $4, so 400. 16 times 25 should be 400. Hey Siri, what's 16 times 25?
16 times 25 is
Okay.
400.
Can we find two numbers? Yeah, I think we can. Two numbers that multiply to give us 400 and add to give us 20. Sorry, two numbers that multiply to give us, 400 and add to give us 20. I think it's, maybe not. 400. Let me go down the list really quickly. I just want to look at the numbers, right, before I submit it. I'm starting to think that we can't, but let me just play with the numbers. So right now, this is where we are. So I'm going to go ahead and put this in a box. I just want to play with the numbers with the thing on the right to see, okay, can they factor, right? So can we find two numbers that multiply to give us 400 and add to 20? All right, so I'm gonna go through the list. Now 400 is what, 20 times 20. So it's 4, you could say 4 times 100. So 4 is 2 times 2. 100 is what, 4 times 25. So that's another 2 times 2 times 5 times 5, right? I want to go through all the combinations and just see if any of them add up to 20. Try it later. So we got 1 and 400, but that adds up to 401. We got 2. Now, if we use 1, 2, what is it? 8 times 25. If we have 8 quarters, it's what, 200? But that adds up to 202. Can we do 3? There's no 3. We can do 4. If we use a 4, we have what? 4 times 25, 100 is left over. But that adds up to 104. Can we do 5? Yeah, we got a 5 in the list. If we use this 5, what is that? 4 times 4 is 16 times 5 is 50 plus 30 is 80. Okay. But that adds up to 85, so that's not good. Can we do 6, 7, 8? We can do 8. So now, if we've used these 3, 25 times 2 is 50. That adds up to 58, so that's no good. We can't do 9, but we can do 10. If we've used this 10 here, we got 8 times 5 is 40. That adds up to 50, so that's no good. Can we do 11, 12, 13, 14, 15, 16? I think we can do 16, right? So if we do 16, if we use this 16, 25 is left over. These add up to 41, okay. 17, 18, 19, 20. We can do 20, right? Oh, okay, I think that's it, right? That's the end of the line, 20 and 20. Because 20 is 4 and 5. So then all we have left over is 20. Okay, I just wanted to check and make sure, right? None of these add up to 20, and that's it. Like, we don't have any more to check. So where we stopped should be it. Okay, I just wanted to check that. I know it was a little bit time consuming, but you know, but it was a good exercise because, you know, that's like, if this is factorable with integer coefficients, then those is going to be somewhere in this list, right? These are going to be the numbers, but none of these worked out, so I'm going to go with that. Like, there's no guessing checking. Like, when you master this technique, you know whether this is factorable or not with integer coefficients. Let's hop back over to Pearson. I barely had breath to finish that. I was totally running out of air. Okay. So let's try this. 4r squared. We're gonna cross our fingers. I feel like there's a good chance we could make a mistake, but we're gonna go with it anyway. Times 16r to the 4 to the power of 4 minus 20 rg plus 25g squared. Okay, let me look at it one more time. This was sum of cubes plus minus plus. Okay, we're just gonna somehow we got outside the parentheses. I don't know how that happened. We're gonna put this back over here. Oh, like this. Oh, wait a minute. And then that's supposed to be a G. I don't know why I put Y. I think my handwriting looks like a Y. All right, I'm gonna go with this. Yeah, I'm gonna go with it. I'm still just trying to think if there's anything else. Okay, let's go with it. Ah, I knew it. I knew we missed something. Let me think about it. 4r squared 5g. Let me think about it. Okay, here. What I'm gonna do, I'm gonna compare it to what they did. I'm gonna have to take some time to see if I can find my mistake. I'm gonna view an example. Sum of 2 cubes, that's what we did. Okay, let's continue. Yeah, 5x squared cubed, right? That's exactly what we got. We got 2r squared cubed. Oh, wait a minute. 4. I think it's okay, because it's 4 cubed. I bet that's where we made our mistake, though. Okay, so here, this is what I'm gonna do. I think I know where the mistake is. I gotta think about it some more. Let me hop back over to the tablet. Okay, so I think it's just the way we wrote it, and it confused us right here, right? Instead of writing 2r squared cubed, instead of breaking it down to the 2, I'm gonna do 4, right? That's 4r squared. So I'm just gonna change my notes here. 4r squared. I'm gonna change this, and I'll do it in purple so it pops. To 4r squared, right? Cubed. Because 4 times 4 is 16 times 4 is 64. R to the power of 6, okay? So now if we have that, so then this 2r, this changes right here. So I'm gonna go ahead and adjust this, because I feel like that's where we had the greatest chance to make a mistake. So this is gonna be our 4r squared. Okay. So then that's gonna be 16. Yeah, so we got 16r to the 4. 4 times 5 is 20. Oh, there it is. I found it. There's a mistake. That's supposed to be 20r squared right there. That's the guy. 20r squared g. That's what we're missing. That's the only thing that looks off to me. Everything else looks like it's okay. Okay. I think we're just missing that one square term. Let's go back, add that in. Let's see if that's it. Let's cross our fingers, all right? Come on, you're supposed to switch over. You might not have been switching this whole time. Come on. All right. Are you tripping? I thought it might not have been switching the whole time. Okay. I'm gonna close this out right here. I think we just forgot. We missed the squared. That's okay. Let me see. I think that looks okay. Let's go with it. Whoo. That was intense. How many more questions? I don't think I want to do any more. Because I said we can get out at 6:20. Let me see. I'm pretty sure the next one, it's like 19:20. There's 3 more. I'm going to leave these for you guys. If you want me to do it, just let me know and I will. But right now, I'm just going to leave it. Okay. Okay. That was fun. So yeah, it's been pretty quiet. I'm gonna have to like mark a whole bunch of people absent. I'm gonna have to go search for a whole bunch of people. But if there aren't any burning questions, let me hop back over to the tablet. Like it's not. Yeah, it's just it hadn't been switching the whole time. That's okay. You live and you learn. And then so in the future, what I plan to do is make it so that okay, like now I would generally like once I get it set up, I'll load the notes now and make them available. Um, but you know I haven't set it up yet. So on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Take care. Peace.